Okay, good evening, everyone. Today we are going to start few revision questions on the Redox chapter. Okay. Good evening, Rashi, Shivangi, Ashi, Karan, Shashwat, Vanna, Arohi. Okay. Yes, just a second. So the first question is, what is the oxidation number of nitrogen in HNO4? And this is slightly tricky question. And the reason it is tricky is that if you calculate the oxidation number just by using the normal method, you consider the oxidation state as X. So H is +1, nitrogen X, oxygen -2, so 4 minus 2, 0. You will get X equals to 8 minus 1, that is +7. But we know that nitrogen maximum oxidation state is +5. Nitrogen has at the most 5 valence electrons. So the oxidation state cannot be beyond +7. And the reason is that the structure, okay, so structure of HNO4 is slightly different. It is like this. HNO4 name is peroxynitric acid. It has peroxide linkage, which you need to remember. Peroxide linkage. So due to this one, the oxygens which are in peroxide linkage will have oxidation state -1, not -2. The oxygens which are not in peroxide linkage will have -2. Now you can calculate the oxidation state of nitrogen using this structure. Yes, Ashi, correct. Devansh, yes, correct. Peroxide linkage. So now if you calculate it, it will be +1 for hydrogen, -1 for peroxide, oxygen, -1 again for another peroxide, X for hydrogen, sorry, nitrogen, -2 for normal oxygen, -2 another normal oxygen. And then you will get X equals to +5, which is the correct answer. Not +7. +7 is wrong. Next question. Calculate the oxidation number of underlined elements. Now these are easy ones. Okay? So if you calculate this one, X plus twice of -2 equals to, because you have +1 charge equals to +1. X equals to 4 plus 1, that is plus. Yes, so yes, Ashi, these ones are easier ones as compared to previous example. Next one, UO2 2 plus. Now tell me the answer quickly, everyone. Yes, Ashi, good. Mehak, Tuhina, Karan, Shashwat, Devansh, Arohi, Shivangi. Correct. Okay, good. So it means you are able to calculate. It will be plus 6 using the same approach. Here, barium Ba2XeO6. You have to calculate of Xe. Consider it as X and tell me the answer. Okay, good. However, check again. Karan, Tuhina. Okay, good. It's simple. Barium plus 2, oxygen minus 2. So twice of plus 2 plus 6 times minus 2 equals to 0. There is no charge. Okay. So it will be 4 plus x plus, sorry, minus 12 equals to 0. X equals to 12 minus 4 plus 8. Yes, Karan, Tuhina, Devansh, Shwangi, Aruhi, correct. Now the next one. K4P2O7. You have to calculate of phosphorus. Tell me the answer quickly. This one is very easy. Yes, Karan, correct. Devansh, correct. Think again. Mehak, Shashwat, correct. Okay, so it is plus 5. Potassium is plus 1. So 4 times plus 1. Plus 2 times X. We have to find of phosphorus. Plus 7 times minus 2. Oxygen has minus 2 equals to 0. Is 4 plus 2x minus 14 equals to 0. 2x equals to 10. X equals to plus 5. Okay. Need to see which one is underlined. Next one. K2S. Yes, Karan, very quick. Good. Devansh, Shashwat, Ashi, Tuhina, good. Shivangi, Rashi, good. Remember, group 1 elements will always have plus 1. So twice of plus 1 plus x to 0, x to minus 2. Next question. Calculate the oxidation number of nickel in NiCO4. And I have already told you that carbonyl group CO has a specific oxidation number. You don't need to write carbon and oxygen. Okay. No, Devansh, no, Ashi, no, Vandana. Okay, okay, Vanda correct. Vanda correct. Okay, 0. Why? Because nickel you will consider as X plus 4 times CO has 0. Overall charge is 0. Means X equals to 0. Yeah, Ashi. Okay. So remember, CO, you don't need to write separately. CO group has combined oxidation state as 0. Iron in FeCO5. Okay, there is something wrong. That's why I skipped that one. Okay, carbon in CH2O. So I'll correct that and then we will do it later on. Carbon in CH2O. Okay, Devansh, Shashwat, Karan, Mahak, Tuhina, Ashi, Rashi, Arohi. Correct. Good. So here the answer will be 0 because carbon plus twice of 1 minus 2 equals to 0. X equals to 0. Next question. Identify the oxidizing and reducing agent in the following reaction. So oxidizing agent will be that one which is getting which is reduced. Reducing agent that one which is oxidized itself, it gets oxidized. Now tell me the answer. Mahak, check again. Your answer, Shashwat, Shivangi, correct? Fe is getting oxidized. Yes, Arohi, correct. That's why I have written. You have to identify the oxidizing agent. Shashwat, correct. Preeta, correct. Okay, now look here. Those who are still not clear, just look. Fe2 plus ionic state, oxidation number plus 2. Fe3 plus oxidation number plus 3 means oxidation is taking place. Fe2 plus is oxidized, hence Fe2 plus is reducing agent. And remember, first you need to write oxidizing agent. So although I am telling you first the reducing agent, your answer should be first which one is oxidizing agent, because in the question first oxidizing agent is written. Okay. Now consider NO3 minus. Before NO3 minus, why I have skipped to H plus? Because H plus means it has oxidation state plus 1, and here also it has oxidation state plus 1. No change in oxidation state. I don't need to consider that. Now NO3 minus. NO3 minus means nitrogen X plus 3 times minus 2 equals to minus 1. NO3 minus X plus 3 times minus 2 equals to minus 1, that is X equals to 6 minus 1, that is plus 5. So here nitrogen is plus 5. Now consider NO2. NO2 X plus twice of minus 2 equals to 0, X equals to plus 4. means it is reduction. Means NO3 minus nitrate ion is getting reduced, means it is oxidizing agent. That is the answer. We will say NO3 minus is reduced, hence it is oxidizing agent. Rather, even don't write NO3 is reduced, NO3 minus. That is something I have written to make you understand. You can just write NO3 minus nitrate ion is oxidizing agent. Okay. And Fe2 plus is reducing it. Obviously, you have to show in the reaction as I have shown. Oxidation and reduction parts you have to show, and the oxidation states also. Don't miss this part. First, write the equation, write the oxidation number, show where is oxidation and where is reduction taking place. After that, write Fe2 plus is, sorry, NO3 minus is oxidizing agent, Fe2 plus is reducing agent. Split the following redox reaction in the oxidation and reduction half reactions. How will you split this? Just waiting for your answers. If anyone can understand how we need to write it in such a form that we can split it in oxidation half and reduction half. Has got it. Very good. Ashi has got it. Very good. Okay. So the key here is, and if you understand that one, that will be the answer. KCl, basically you have to write as K plus 2Cl minus. Once you have written in this way, you can find this one is oxidation, this one is reduction. Because in their elemental form, the oxidation states are zero. So here, potassium and chlorine will have oxidation states 0. But in ionic form, their oxidation state will be +1 and -1. So 0 to +1 increasing oxidation, 0 to -1 decreasing reduction. So that's what you need to write. Oxidation half, reduction half. Remember, first you have to write the reaction as I have written. And then write this, oxidation half and reduction half. You have been asked to split the reaction in oxidation half and reduction half. After that, the second part. Split this one now. This one is easy. Find where oxidation is taking place, where reduction is taking place, and split it. Shivangi, yes. Mehak, correct. Yes. You are just skipping one thing, okay? You are missing one thing which you have to consider because charges are not balanced. If you see, okay, Ashi, yes, Ashi, good. Ashi has considered that thing. Devansh, yes, correct, but consider the charges also. When you split in two halves, you have to balance the charges as well. Yes, Devansh, correct now. Yes, Rita, good. Or yes, oxidation half is correct. Balance the charges as well. Okay. Shashwat, yes, correct. You have balanced the charges. Good. So in this case, what I am saying basically, you have to balance the charges by adding appropriate number of electrons on a side to have the same charge on left hand side and right hand side. Not just one electron in second one. Okay. In both cases, there have to be same number of electrons. If it is balanced reaction, yes, Tuhina, correct. Now, another point to see, as I have told you that if it is loss of oxidation, sorry, loss of electron, that is oxidation. So always remember loss of electron is oxidation. So in first reaction, there is loss of electron. It is losing electron. So it will be oxidation. So sometimes reaction might not be given. Just you might be given that it loses some electrons, few electrons. It means that part is oxidation. To remember that term is, which obviously does not exist, but you need to remember loxidation. Loxidation means loss of electron is oxidation. Next question. Arrange the following molecules in decreasing order of oxidation state. So again, the same question to calculate the oxidation state and then arrange these in decreasing order. Means highest to lowest. So if I calculate here, it will be plus 4, it will be minus 3, it will be minus 1 by 3, NO2 minus, it will be 4 minus 1, that is plus 3. Okay. Minus 2, it will be minus 2, isn't it? Then arrange them. Okay. Highest to lowest means first, second, third, fourth, fifth. Most positive to most negative. Yes. Correct answer. Very important question. It appears quite a few times in your examinations. Nitric acid acts only as oxidizing agent, while nitrous acid acts both as oxidizing as well as reducing. Explain why. The answer is that nitric acid is already in its highest oxidation state. Yes, Ashi, correct. Nitric acid is already in its highest oxidation state. As I told you, that nitrogen highest oxidation state is plus 5 because it has 5 valence electrons. It cannot be more than that. If nitric acid acts as a reducing agent, suppose here the question is nitric acid acts only as an oxidizing agent. So suppose it can act as a reducing agent. In that case, it should get oxidized. For nitric acid to act as reducing agent, it should get oxidized. That is, its oxidation number should go beyond plus. As nitrogen cannot have oxidation number greater than plus 5, HNO3 cannot get oxidized. Hence, it cannot act as reducing agent. Clear? This is something what we have already discussed: oxidizing agent, reducing agent. Oxidizing agent means it oxidizes. Oxidizing agent, it oxidizes other. So if I say A is oxidizing agent, means A oxidizes, say B. A itself gets reduced. This concept should be very clear. Okay. If you are not clear about it, then write these 3 statements and go through these again after the class. If A is oxidizing agent, it means A oxidizes, the other one, A itself gets reduced. Understand all these statements, what I have written. If there is any confusion, let me know. Okay. Now we consider nitrous acid. The question is that nitrous acid can act as oxidizing as well as reducing agent. Now, in case of nitrous acid, The oxidation number of nitrogen is plus 3. That is plus 1 plus x plus 2 times minus 2 equals to 0, x equals to plus 3. 4 minus 1 plus 3. Now, if it is plus 3, then it can increase to plus 5, it can decrease to minus 1, it can decrease to 0 also. So, in this case, it can increase or decrease. Oxidation number of N can increase by losing electrons or can decrease by accepting electrons. Thus, HNO2 can act both as oxidizing as well as reducing. So, this is neither maximum nor minimum. Minimum oxidation state for nitrogen will be minus 3 because it can accept at the most 3 electrons. It already has 5 electrons. So nitrogen atomic number 7, 2, 5. So either it can gain 3 electrons and it can be 2, 8. It means minus 3 oxidation state. Because when it gains the electron, it is negative charge. That's why negative oxidation state. Another possibility is that it loses these 5 electrons and gets only 2. That is duet in the first shell. It is losing 5 electrons plus 5 oxidation state. So minimum is minus 3, maximum is plus 5. So if there is in between, there is a possibility that it can get oxidized or reduced, which is the case of HNO2. If you have any confusion, I would suggest that you write the answer and then it will be clear to you. Next question. Can the reaction, this one, be regarded as a redox reaction? Again, this one is very common question asked in your examinations. Just 1 mark question. The ways, if there is change in oxidation state and there is 1/2 oxidation, 1/2 reduction, then it can be regarded as redox reaction. But here if you see chromium oxidation state, remember H2 is in normal state, H plus 1, oxygen minus 2. Here also hydrogen plus 1, H plus means plus 1. So there is no change in oxidation state. We don't need to consider H. We just need to consider Cr2O7. Okay. Means dichromate and chromate. 2x plus 7 times minus 2 equals to charge. Charge is minus. Okay, Shashwat says my voice is not clear. Just others let me know whether I am clear or not. Okay, so most of you say it is clear, clear, clear. A few of you say that it is buffering sometimes, and others says fluctuating, okay, or fading. Okay, so for most of you, it is clear. So it seems there is no problem at my end. Otherwise, no one would have. Rashi, I'll discuss it with after this question. Okay, your question I'll take after this one because that is uh, if it is not till neon, it is out of syllabus. Okay, so that is something. If you are talking about it is JEE and even not NEET, only JEE. Now, because your teachers follow books like Prateep and those are specifically for JEE. That's why those questions are there. So here 2x minus 14 equals to minus 2, 2x equals to 14 minus 2 square, x equals to plus 6, x equals to plus 6. Now here also calculate x plus 4 times minus 2 equals to minus 2. X minus 8 equals to minus 2, x equals to 8 minus 2, that is plus. So there is no change in oxidation state of chromium. So neither oxidation nor reduction, it cannot be regarded as redox reaction because there is no change in oxidation number. So the reason also you need to mention that it cannot be regarded as redox reaction because there is no change in the oxidation number. No, no, no. We need to consider only chromium. That is something for balancing. Okay? To find out whether there is oxidation or reduction, we just need to consider at atomic level. Now, the question Rashi had. Okay, your question was Rashi, sir, while we calculate magnetic nature, how do we calculate of the molecules like NO2 or any other? Because in book, it only have like O2 and C2, etc. First of all, there is easier way. Okay, although NO2 is beyond the molecular orbital theory, so you don't consider the molecular orbital theory. Okay, for that you just get the central atom, that is nitrogen, NO2. Okay, and after getting all electrons bonded, if you think that there, if you find there is any unpaired electron or unbonded electron, then you say that will be paramagnetic. Okay, so even beyond molecular orbital theory, we can find out whether the molecule will be paramagnetic or diamagnetic based on whether the electronic structure of the central atom will have paired or unpaired electron or not. Okay. More about it, you will study in 12th grade in coordination compounds. Okay, in coordination compound specifically, we will be talking about that, but this year coordination compound has been removed from 12th grade. So that is very important chapter. Uh, Rashi, that itself is an example. For example, NO2. Okay, and for that you have to remember the structure. That is another requirement. If you don't know the structure, it will be difficult for you to find out whether any molecule will be diamagnetic or paramagnetic if we are not applying the molecular orbital theory. Okay. Yes, any other question or you have confusion in this question, just let me know before I move forward. Okay. Good. If you want, Rashi, maybe in any other class or theory class, I can explain it through the structure also. But for that, you need to know the structure, NO2. And I hope you are talking about NO2 only because NO2 exists as dimer also. Okay, and 2O4. And N2O4 is not paramagnetic. NO2 is paramagnetic because it has, obviously, because I know the structure, that's why I am telling you. NO2 is paramagnetic, but its dimer N2O4 is not. So because the oxidation state of chromium is same, it does not change, it cannot be regarded as redox. Yes, Rashi, for Ti2 plus, we have the similar thing, but not based on the structure, but based on whether the electronic configuration of Ti2 plus, for example, if you write, that will have the unpaired electrons or not. Okay. I'll explain it, diagrams. Okay. Maybe in the next class, I'll have some diagrams, and on that basis, it will be clear. Which of the following equations represent oxidation reduction reaction? So basically, it is asked which one is redox reaction, which one is not. And very simple one, remember that because you have peroxide and simple oxide, it means there will be change in oxidation state for at least one. But you have to remember whether there will be oxidation and reduction both or not. Okay, Rashi, if you have paper tomorrow, then you can call me maybe around 9 o'clock today. Okay? I will explain. So here, if you see, hydrogen oxidation state will not change, but oxygen due to peroxide linkage, it is -1. Here it is -2. Potassium oxidation state cannot change because it is group 1 element. Okay, it will have -2 +1 +1. Their normal oxidation state. Here it will have +1 +1 -2. The normal oxidation state. Whether it will be -2, that is something tell me. KHO2. What will be the oxidation states? Potassium, remember, I have already told you, potassium will not change its oxidation state. Tell me oxidation states of hydrogen and oxygen in KHO2. Okay, Devansh, if it is so, there should be a charge on KHO2. Preeta. Okay, Preeta, how do you say that KOH is reduction of, just a bit if you can explain? Okay, the answer is no. Okay, the reason is that yes, there is oxidation, sorry, reduction. In this case, here there is no change in oxidation state of potassium, hydrogen, or oxygen. Sorry. For redox reaction, there must be oxidation and reduction both. Clear? But here only reduction is taking place, no oxidation. Next one. Tell me the answer. Okay, Mehak. Good. Ashi, good. Karan, good. Yes, Preeta, tell me the answer, whether it is redox reaction or not. Yes, Shivangi, good. Tuvina, good. Preeta, Ashi. Ashi, because group 1 elements will always have oxidation state +1 without any fail. Group 1, group 2, group 1 will always have +1, group 2 always +2, aluminium always +3, fluorine always -1. So they do not depend on the compound. Chromium here will have +6, chromium here also +6. No change. It is not a redox. Clear? Now this one. KO2, KO2. Whether it is redox reaction or not. Okay. Mahak Ashi, correct? Okay, Devansh, think again. The reason is this one is actually an ionic means Here, potassium and oxygen are in their elemental form. And here it is K plus O2 minus. Yes, Shivangi, Rita, Ash, correct. So here you have oxidation because it is going from 0 to plus 1. And here it is reduction because it is going from 0 to minus 1. So a few facts we have to remember that K plus O2 when potassium superoxide is formed, KO2 means potassium superoxide, then it's an ionic equation and it is a redox reaction. Yes, Tuhina, O2 is oxidizing agent and potassium is reductant. Next one. This one is straightforward. Nothing to think much about. Aline, give me my phone. That's why I asked you not to take my phone. But you don't listen to me.